Pre-calculus lesson 2.4, dividing polynomials and the remainder and factor theorems. In previous lessons, we've talked about how to do operations with polynomials, but that was addition, subtraction, multiplication. In this case, we want to make sure that we're able to also divide polynomials. So in order for us to do that, though, we need to go back to 4th grade and remember how to do our long division. So in this case, what we're going to be doing is we're going to take 144 and divide by 4. So let's go over this mechanic. First off, what we want to do is think about how many times can 4 go into 14? Well, and that's going to be 3. And so we're going to put the 3 above the 4. From there, then, we're always going to take that number and multiply by the number we're dividing by, in this case, the divisor. 3 times 4 gives us 12. And so from there, what we're going to do is bring down that 12 and then subtract. Well, 14 minus 12 gives us 2. And then we're going to go ahead and bring down the next column, in this case that 4, get 24. And then we're just going to go again. We need to think to ourselves, then, how many times can 4 go into 24? In this case, that's going to be 6. So we're going to put that 6 up on top, multiply again. And that right there is going to give us 24. And we're going to subtract once more, and that gives us 0, which in this case would be our remainder. So this means 144 divided by 4 gives us 36 with a remainder of 0. Polynomial long division is going to work very similar to that same mechanic. Take, for example, if we wanted to divide 6 cubed minus 19x squared plus 16x minus 4 by the binomial x minus 2. We're going to go ahead and put that x minus 2 on the outside, and then our larger polynomial on the inside. In the case of dividing, though, we always want to look at the very first 2 terms. So for this example, the x and the 6x cubed. We need to think to ourselves, well, x times what will give us 6x cubed? Well, that would be 6x squared. So then what we're going to do is we're going to put that 6x squared on top and then distribute that to every term that we're dividing by, in this case, both the x and the negative 2. 6x squared times x gives us that 6x cubed, but then 6x squared minus 2 gives us a negative 12x squared. From there, then, we can go ahead and subtract. We note that the 6x cubes are going to cancel out, but if we go ahead and take the negative 19x squared minus 12, well, that's really going to be like adding a positive 12, and that's just going to give us a negative 7x squared. And then from there, we're going to go ahead and bring down the 16x and go again. So in this case, we want to think, well, x times what gives us a negative 7x squared? That would give us a negative 7x. And so we're going to go ahead and multiply both the x and the minus 2 by the negative 7x, giving us a negative 7x squared plus 14x, and then we're going to subtract. That's going to cancel out the 7x squareds, and then 16x minus 14x gives us 2x. And finally, then, we can bring down that negative 4. So then we're going to go one more time. We need to think, what x times what give us 2x? In that case, it's going to give us a positive 2. So if we go ahead and distribute that 2 to both the x and the minus 2, that gives us a 2x minus 4, which if we go ahead and subtract one more time, cancels everything out because it's changing to positive again. The remainder is 0. So our answer here would be 6x squared minus 7x plus 2 with no remainder. Let's try this again, but in this case, we're going to be dividing by a trinomial. We're going to take the x squared minus 2x plus 3 and put it on the outside. And then we'll put the quartic, the x to the 4th plus 3x squared plus 1. Notice here, though, since we are skipping the x cubed term, we're going to go ahead and put in a filler 0x cubed. Anytime you're missing a term, you need to go ahead and put a 0 in there so we're not missing it. Same thing with the x term. We're going to put in a plus 0x. This helps keep our mechanic in line and doesn't make us error on in the problem. So again, we're going to go from x squared to x to the 4th. Well, x squared times an x squared gives us x to the 4th. So we're going to distribute that x squared to all 3 of the terms. From there, then, we're going to go ahead and subtract. And notice the x to the 4th cancel out, but this is where that 0 comes into play. So we're going to have that 0x cubed minus a negative 2x cubed, which really means we're going to be adding 2x cubed, so that's a positive. And then we're going to get our 3x squared to cancel out, giving us a 0x squared, still writing it. But then I'm still going to bring down that 0x to keep our places in check. So then we're going to start again. Going from x squared to 2x cubed, well, we need to multiply by a 2x. So we're going to distribute that 2x to all three of our terms, giving us a 2x cubed minus 4x squared plus 6x. And then if we go ahead and subtract, the 2x cubes will cancel out. We'll get a positive 4x squared and then negative 6x, and we're going to bring down that plus 1. And so then finally, we're going to go one more time. We need to think about how do we get from x squared to 4x squared. Well, in this case, we're going to multiply by 4. We go ahead and distribute that 4 to all three of our terms. We'll get a 4x squared minus 8x plus 12, leaving us with a 2x minus 11. This right here is going to be our remainder. Notice how the degree of the remainder, which is 1, is 1 less than what we divide by, the x squared trinomial. A remainder should always be 1 less, okay? 1 degree less. There's also a proper way for us to write our solutions, in this case our quotients, which is our final answer, using our remainder. And we're going to write this as such with our final answer of x squared plus 2x plus 4. But then since we have that remainder, we're going to write it as a fraction, a 2x minus 11 over what we divide by, the x squared minus 2x plus 3, since that is like our fraction of what's left over, the leftover divided by the total. This is the proper form to write your solutions to a polynomial division problem if there is a remainder. Now, long division's very nice and all, but it can be a little lengthy. The great thing here, though, is that we also have another way to divide polynomials, and this is synthetic division. Synthetic division, though, only works when we are dividing by a binomial. So like in this case, we're dividing by x plus 3. Synthetic will only work if it's of the form, a binomial of the form x plus or minus a number. Otherwise, we have to use long division. Our steps for synthetic division, which you might remember from Algebra 2, is first to write the 0. Number 2 is then to list the coefficients in standard form, i.e. going from highest to lowest exponent. From there, then what we're going to do is add our columns down and then always multiply by our 0. And then finally, we want to rewrite our final answer. So let's try these steps. Step 1 is always to find our 0, and we're going to find that 0 by setting what we're dividing by to 0. And so if x plus 3 is our factor, negative 3 is going to be our 0. And so we're always going to go ahead and write that and box that in the top left corner. The next thing we want to do is go ahead and write out our coefficients in decreasing order of exponents. So you notice here that I went ahead and listed it out. Since x cubed was our first, then be x squared, then x, and then the c is for constant. Well, I'm just writing the coefficients in the proper order. 1 for the cubed term. Since we're skipping, we don't have a quadratic term, I'm going to put a 0 there, just like we did with long division. And then I'll put a negative 7 for our x term, and then the negative 6 for our constant. We're never going to include our x's here, just the coefficients. The next thing we want to do here then is go ahead and draw a line in our add sign, because our mantra here is now to add then multiply. You're always going to bring down and add that first column, which will give us a positive 1, but then we're always going to multiply that number by what our 0 is, in this case a negative 3. So if we take 1 times negative 3, we're going to get negative 3, and then we're just going to add down again the next column and get a negative 3. And then we're going to multiply that negative 3 by our 0 in the box, which is negative 3. So negative 3 times negative 3 gives us a positive 9, which if we add down that column gives us a positive 2. Then we're going to take that positive 2 and multiply by the negative 3, giving us a negative 6. And then we're going to add down that column and get a negative 12. That negative 12 right there represents the remainder. And so you'll notice here that down below, if we look at what's underneath our line, we have the 1, the -3, and the 2. Those right there represent the coefficients of our solution. But in this case, since we were dividing by an x, we're actually taking one x away from the original polynomial, which was a cubic. And so that means the degree of our solution is going to be 1 less, which is going to be a quadratic. So our final answer here will be 1x squared minus 3x plus 2 plus our remainder of -12 over the binomial, which we divide by the x plus 3. Let's try this again with another problem. Again, the first thing we're going to do is find our 0. So in this case, we're dividing by x minus 3, so our 0 is a positive 3. From there, we're going to list out our coefficients going across. Notice how we're skipping a cube term, so I'm putting a 0 in there, but all the other terms have a coefficient, so we can just write those out. And then from there, we can go ahead then do our adding and multiplying. So we're going to bring down that 5 from the first column, multiply by 3, which gives us 15. Add down, which will give us another 15. 15 times 3 is 45, which if we add down is 49. We take the 49 times 3, that will give us 147, which if we add down, gives us 142. We multiply one more time, we're going to get 426. If we add down, we'll get that 431. So this case then, or 431, is going to be our remainder. So since our original polynomial was degree 4, then that means the degree of our solution is going to be 1 less than that, which in this case would be x cubed. So remember that final line is the coefficients of our answer, so we can rewrite our solution as 5x cubed plus 15x squared plus 49x plus 142 plus a remainder of 431 all over x minus 3. This problem right here would be a lot harder if we were trying to do long division. This is why we really like synthetic division, and we'll continue to use that with graphing our polynomials, which we'll get to next. The cool thing about synthetic division is also that it leads into a remainder theorem. The remainder theorem says that if a polynomial f of x is divided by the factor x minus c, where c is a constant, then that remainder is f of x. So for example, if we were to divide, or so in this case, if we were to divide by x minus 1 and get a remainder of 2, then that means then that f of 1 would be equal to 2. It would be the exact same thing as plugging in 1 into the original polynomial and getting out 2. So whatever the remainder is going to be the same thing as that function operation. So let's use the remainder theorem to find f of -4. We're still going to use synthetic division, but instead, in this case, of changing the sign, we're just going to leave it the same since it's already giving us the 0, not the factor. So we're going to put -4 in our top left corner, and then list out our coefficients. Since we are not having any missing terms, we don't need any zeros, so we can go ahead and continue from here to add and multiply. So we're going to add down the 3, and then we'll multiply that by the -4, which will give us a -12. Add down there, giving us a -8. Multiply, get 32. Add down and get 27. And then 27 times -4 is going to give us that -108, which if we add down, will give us -105. Since that -105 is our remainder, then that means then that f of -4 is going to be equal to -105 by the remainder theorem. So this would be the exact same thing if we were to go ahead and plug in -4 into the original f of x. Why don't you pause the video here and try that on your calculator to make sure that it turns out correctly. Let's try synthetic division on this one, but then use a remainder theorem to find f of 2. So again, we're going to go ahead and put that 0 in the top left corner and lift out our coefficients. In this case, notice we're missing a fifth term, a cube term, and our x terms, we're going to put zeros in for each of those. Once we have listed out our coefficients, we can go ahead and start adding and then multiplying by our 0, in this case that 2. So we're going to bring down the 1, and then multiply by 2, giving us a 2. Add down, give us a 2 times 2, which is a 4. Add down, notice the 4 and negative 4 cancel each other out, still giving us 0. If we add down the next column, still giving us 0. Multiply again, still giving us 0. But then we can add that 3 down. 3 times 2 is 6. Add down gives us 6. 6 times 2 is 12. And then finally, if we add that last one, we're going to get 14. That 14 represents our remainder, but even more so, by the remainder theorem, we know then that f of 2 will be equal to 14. So it would be the same thing as plugging in 2 for all the x's and evaluating. Pause the video here and go ahead and check that on your calculator. A special case of the remainder theorem that we can actually go even further with is called the factor theorem. The factor theorem that says that if we let f of x be a polynomial, and we find that f of x is equal to 0, then the factor x, the binomial x minus c must be a factor of f of x, and vice versa. So this says then pretty much that if we get a remainder of 0, then that means we have found a factor of the polynomial, because it's going in perfectly into the polynomial, dividing with no remainder. So let's go ahead and try this and show this is how it's going to help us find all the zeros for a polynomial that is greater than degree 2. So like in this case, it says solve the equation, which is 15x cubed plus 14x squared minus 3x minus 2 equal to 0, given that negative 1 is a 0. Well, by the factor theorem, if negative 1 is a 0, then that means that we can use that as synthetic division. We know that x plus 1 must actually be a factor of this polynomial, since negative 1 is the 0. So we can use synthetic division here to help us actually produce this polynomial to find the others. And so if we use that negative 1 as our 0 and go ahead and write out our coefficients and perform our synthetic division, let's go and bring down that 15, multiply by negative 1, which gives us a negative 1 times a negative 1 gives a positive 1. And so then we can go ahead and add down, get a negative 2. And then we add those two together. That means we get a remainder of 0. So that remainder of 0 means that we have a factor. But then what can we do with that? Remember, those numbers left over represent the solution, or the leftover polynomial. So we can actually go ahead and write that as 15x squared minus x minus 2. And so if we were to take that solution times the factor of x plus 1, this would be the same thing as the original polynomial. And so notice that 15x squared minus x minus 2 is a quadratic, which we know how to factor. So by using our synthetic division to break down the original polynomial, we broke it down to something that we actually know how to handle. This is where synthetic division is going to help us solve higher order polynomials. So if we go ahead and take that 15x squared minus 2, we can go ahead and actually do some factoring. Notice in this case, we can use our cross method. So our a times c is going to be negative 2 times 15, which is negative 30. And then we're going to add to the b of negative 1. So we need two numbers that will multiply to negative 30, but add to negative 1. Well, in that case, if we think about all the numbers that multiply to 30, 6 and 5 work, and they have a difference of 1. And in this case, the negative 6 and the positive 5 are going to add to that negative 1 that we want. So then we can go ahead and split that negative x, we're using that quadratic, into the four terms, 15x squared minus 6x plus 5x minus 2. Then we can use our grouping here. On the first two terms, we can take out a 3x, leaving us with a 5x minus 2. And of the second two, we can only take out a positive 1. So this gives us the two factors of 3x plus 1 and 5x minus 2. And so now we have all the factors of the original polynomial, but since it says solve, we actually need to set those equal to 0. And so if we were to do this, we're getting all our factors here of 3x plus 1 5x minus 2, then also the x plus 1. But since we actually need to solve, we need to set these all equal to 0. And so we'll get our x values here to be a negative 1/3, 2/5, and a negative 1.